Hi, in this video we are going to pay special attention to chromosome number 23 because chromosome number 23 or the pair is called the sex chromosome. So it determines the gender of a person. So here I have a karyotype of a person. A karyotype is just a photograph of all its chromosomes, of all the person's chromosomes. So if you notice, there are 23 pairs of them, and if you notice, they are in pairs. So again, they are in pairs because one comes from your mother and one comes from your father. So if you take a look at chromosome 23, which is this one, you would notice that one chromosome is quite longer than the other. So this longer chromosome is an X chromosome, and then this shorter one is the Y chromosome. Now, the way that I can rationalize, that I can think about it is, I think of X and Y, and I really think that Y is just an X, but you removed a part of it. So, because you are removing a part of it, it is shorter. So, in real life, the way you really recognize the X and Y chromosome is that the X chromosome is quite longer, and the Y chromosome, its pair, is quite shorter. And remember that during meiosis, or yeah, during meiosis, they kind of pair up in homologous pairs, and during mitosis, they line up at the center in a vertical manner. So it's pretty easy to kind of determine which chromosome is which. But the point is, unlike other chromosomes, which are usually equal in size, chromosome number 23 is like this. So if you see chromosome number 23 to be like this, they are equal size. That means this is chromosome X and that is also chromosome X. And if you see something like this is chromosome X and this is chromosome Y. And this gives you this person, if you have a chromosome like this, becomes male, becomes a boy, and this person here with an XX becomes a female. So please take note that again, XY means male, XX means female. Now, to kind of just give it the connection to our previous discussion about, some aspects of your reproductive system, you have to remember, and also in mitosis and meiosis, why you need to create haploid cells. You have to remember that a sperm cell must meet with an egg cell. So this is egg cell. This is the sperm cell. And again, that egg cell contains 23 chromosomes. And this sperm cell also contains 23 chromosomes. When they join together, you would have a 46 chromosome zygote. And that zygote is the one that divides and becomes a baby eventually. Like zygote is just a fertilized egg. So basically, the sperm cell injects itself into the egg cell and it releases its chromosome. So meaning the 23 chromosomes of the egg cells can be now mixed with the 23 chromosomes from the sperm cells, creating the whole set of 46 chromosomes, right? Now, why am I why am I explaining this? Because this is important for chromosome number 23. Therefore, the egg cell, the egg cell will always have an X chromosome. Okay? Again, the egg cell will always have an X chromosome, while the sperm cell could either have an X or a Y. Okay? So, in other words, all egg cells will always have an X chromosome, but sperm cells can either have an X chromosome or a Y chromosome. So, therefore, the determination of gender is really decided by what chromosome 23 is brought by a sperm cell. Because if the sperm cell brings an X chromosome, it meets the egg, it results to XX, which is female, right? But if the sperm that fertilizes the egg happens to be one that contains Y chromosome, then it would be XY, which would mean it would become male. Okay, so again, that's just an important aspect. That all egg cells contains X chromosomes, but sperm cells could have an X chromosome or a Y chromosome. Okay, now aside from that special bit, we would also like to kind of explain the action of this. Remember, chromosomes code for proteins, right? Code for proteins. So the way I think about it is, think about it as X is really proteins for female characteristics, right? And then if you have another X, so now you have two hormones with female characteristics. So the female characteristic is kind of reinforced, and that's why you have a female body. But if you have an XY, what happens is at first, because you have an X1, an X chromosome, the body of that growing fetus would actually be female-like. Female-like meaning it will have, ovaries, right? But it's only during it's estimated that during week 6 of conception or week 7 or somewhere along that time, it's only then that the Y chromosome is implemented by the cells. So what I mean by that is it's only then week 6 when when proteins here that are for male characteristics are kind of expressed into proteins. So what happens is this kind of dominates, kind of drowns the female characteristics and makes it male. Okay? But this is important because it's kind of interesting to me because it means that all fetuses, when they were conceived, when they were a zygote, when they develop, they actually assume a female gender because of this X. And it's only during week 6 or 7 or along that range that when the Y chromosome is read, if it has a Y chromosome, if it has no Y chromosome, then it just continues and amplifies the female characteristic. But if it has a Y chromosome, the zygote, I mean, what happens is at week 6, that Y chromosome starts to produce proteins that kind of transform the body from female to male. And if you remember our discussion in reproductive system, or remember that in the body, I'm terrible at this, but in the body, remember that the ovaries are somewhere here, right? Somewhere in the navel, right? And then what happens is, during the first few weeks, the ovary is actually developed there. And then when week 6 or 7 comes in and the Y chromosome is read and proteins for the male characteristics would, kind of override the default, what happens is this ovaries descend downwards and becomes the male scrotum. Okay, so what is my point here? My point here is just to kind of have this to point out an interesting fact, and that interesting fact is all fetuses are actually female like at the start, and it's only during week 6 or week 7 that if there's a second X, it amplifies that female characteristics and the baby becomes full-fledged female. But at week 6 or 7, if the fetus or the zygote has a Y chromosome, then the proteins from that Y chromosome would start to influence or change the characteristics from female to male. This is when the testicles descend. The ovaries kind of get converted to testicles and they descend towards here. That's why there is, if you are familiar, there is a condition called undescended testicles. So sometimes the testicle kind of doesn't descend downwards here. So there's a condition like that. But it's interesting because again, my point here is kind of to give you an insight into gender biases and inequality or something like this. Again, this is my attempt to kind of infuse gender equality topics into our science topics, because a lot of times males get arrogant and they say, male is the dominant gender because we are stronger. Nope. Science tells us that the default, let me repeat, the default sex or gender is female. It's only during week 6 or 7 when the Y chromosome is read that the female characteristics is actually changed to male. So the default is female, not male. So some people who are actually kind of sexist actually base their reasoning from the Bible, saying that the female was taken from the rib of the male, fashioned out of the rib of the male, and created into a female, not understanding that that's just a metaphor. But in reality, instead of the female was fashioned out of the rib of a man, in fact, it's the opposite. the male body is actually based from the female body, because we know that zygotes, when they develop, they are female-like because of the Y chromosome. But if there's a second, because of the X chromosome, if there's a second X chromosome, that means the female characteristics are amplified. But if there's a Y chromosome, that female characteristic will be kind of drowned out with the proteins created by the Y chromosome. But this only affects up to after 6 weeks or 7 weeks of development, and we conform to male. So you don't have that reason to kind of base your unfounded your biases, your sexist beliefs, just because the Bible says that the female body was fashioned out of the rib of the male. Again, I'm not trying to bash religion here. I'm just trying to teach a lesson to people who are, male supremacists, saying that the male is the stronger gender. No, based on biology, the fact that the fact that the male body is fashioned from a female fetus, that means the stronger sex, or in this case, in the context of this, is the female. Now, I'm not being sexist also to the men. I'm not saying that men are weaker than female. There are things that, physically speaking, for example, strength, those things, men are stronger. But in other stuff like emotions, females can handle emotions. And again, as I told you before, if you look at suicide rates, there are a lot of suicide. There is a higher suicide rate for men because they can't handle emotion. We can't handle emotion. Female are emotional, and that's not a bad thing. Being able to show emotion is good stuff. It releases stress. That's probably why suicide rates of female are kind of down, are lower than men. So again, what is my point here? My point here is just to point at certain interesting facts about how gender is related to the chromosomes, and kind of teach you a little lesson also on gender equality, that we shouldn't base our valuations of gender, which one is stronger and which one is not, because in reality both are important. Without men, without women, we cannot propagate our species, so they are equally important. So don't use the Bible or other beliefs to back up your uh, your bias that men are stronger, or men is the more important sex, or whatnot, right? So that is the idea for this video. And again, um, remember how gender arises from the chromosomes, how the sperm contains X and Y, but the egg cell only contains X, and how in reality the male body is actually fashioned out of the female body. Again, all babies start to be female-like. When there is a second female chromosome, it amplifies the female characteristics. But when there's a Y chromosome, it kind of changes the characteristic from female to male. But still, it doesn't change the fact that all zygotes are female-like the first weeks of life. Okay?